Hello everyone. So in this talk, we are going to talk about Spark streaming for MQTT using Scala PB. Mostly I will be talking about Protobuf in the beginning and little bit about MQTT, and then what we have in Scala for Protobuf. So just to present myself, I'm Nitya Nand Yadav. I'm a data engineer in Paris and currently working for Neolink. And if you are ever interested to work in Paris, or if you want to move, you can come and say hi to us. It will be our pleasure. So here is the agenda that we are going to follow in this talk. We will talk about Spark streaming, and then the Apache Bahir project. It's important about the MQTT as well. And then we will talk about Protobuf and Scala PB and some issues that I faced in Spark structured streaming for MQTT and some optimizations in Spark. So as I will talk more about MQTT because I am going to use this term several times in this talk. I want to just spread some light over it, what it is exactly. So MQTT is a lightweight messaging protocol for small sensors, mobile devices. So it basically works in the same manner as publisher and subscriber. So there are MQTT clients who publish to some topics, and there are listeners, MQTT client listeners. They will subscribe to different topics, and they will read the message inside these topics. In industrial world, where they manufacture lots of industrial materials, like my previous client, they used to make lots of, they work in glass industry. So they produce lots of glass and building construction materials. So all these machines, they have lots of sensors. So there can be the sensors to measure the temperature. There can be sensors to measure the rotation of the wheel, and the process start time, the batch, at what time the batch is started and at what time it ends. So there are lots of data inside in these machines. But at the industrial level, there is a project which is called Eclipse Tahu. So they implemented this MQTT client, MQTT over their system to get all these data and to provide inside the broker. So usually they call it SCADA. SCADA is like supervised control and data acquisition. So it's industry standard. They follow all over. So, and in this application, they use Google's Protobuf to serialize the data. As we are going to talk about Spark streaming, I hope most of you are aware of Spark. Spark streaming is just an extension of Spark core API. It's like for scalable or high throughput, fault tolerant streaming processing for live data, but it is not exactly real time. It's a micro batch of data. And the interesting part is we can apply higher level functions over these data and to process these data. And in this case, like data, they can come from various sources like Kafka, Flume, or any TCP, or in our case, it will be MQTT. And we will process this data, and then we will push the data to store somewhere in the SDFS or live dashboards. Because okay, so now we are going to talk about MQTT, but MQTT was supported by Spark till version 2.0, And because of very low use and high maintenance, so they removed it from the Spark project. But there's another project which is called Bahir. So they provide the extension for Spark, Apache Spark and Flink. So if you ever get a chance to look all other extension or connectors they provide, it's a very nice library. And they for MQTT they provide the Spark structured streaming and dstream. And the latest version that's supported by Bahir is 2.3.4. So here is the simplified architecture of the project. So there are several factories who produce the construction materials or glass. They are connected to the MQTT broker over GAN, is like generic access network, very low bandwidth. They will push the data to the MQTT broker, and the Spark application, it will subscribe to different topics to read the data. And we will process inside Spark Streaming, and we store it inside the HDFS, and then it can be used by the data analytics team or by the data science team. So moving to the Protobuf. The Protobuf is a project of Google. So they created this project. It can be described as a data structure for it's a data structure to communicate between the machines. So how it works, like we have a message here which has these fields like query, page number, or results per page. So this is a proto file example, but in Scala they can be represented as case classes. So we have this equivalent of case class. So when we compile our program using Protobuf, Scala PB, it will create the equivalent case class. So as in the binary format of Protobuf, it's very easy to define this structure of the data. And on the other side, like on the client side, we can read or deserialize this serialized data. I will give example in in coming slides. So here is the example of a message which is more nested. Like we have a person with a name and ID and phone number, and we have address. So address can be another message where we have the street name, house number, city name, or zip code. So the equivalent of this in Scala will be a case class, person case class with the same fields, and another case class with the address. So it's a very simplified version of the protocol buffer. So when we have this, a case class like is the representation on the client side, and if I initialize these fields with some values, so this is the byte array representation. So it's very compact in this sense, and just to communicate between the machines and to transfer between the machines, it's very lightweight and is very easy. Easy in the sense it's language neutral, because Protobuf is supported for various languages. I will talk about that in coming slides as well. So once the data is in a serialized format, and like it can be serialized using Java language, and we can deserialize inside Scala, because the proto file, the proto file that we have here, it can be shared between different languages, and when we deserialize this language, we will get the message inside it. So in this way, it's very it's language neutral. So these are some features, like we can communicate between different machines, and we can store the serialized data. So in that sense, it's like flexible, efficient, and the best part is the serialization and deserialization is generated automatically, like the classes to serialize and deserialize the message is generated automatically by Protobuf compiler. So it will generate the source code. In our case, it will generate the case classes to serialize and deserialize. And in Protobuf, they provide support for Java, Python, and C, but there is no direct support for Scala. So for this, this guy Nadav Samit, he worked in the initial project of Google Protobuf, and he helped to create. He created the Scala PB library, and we will talk about that as well. Another benefit of using the Protobuf is like with the time, like when we start working on a project, the client's demands, they keep changing. So here in this case, like if initially the client asks just to have name, ID, and email, and over time they want to evolve the schema and they want to add the address. But even after schema evolution, we are not going to break any code on the client side because we can easily add or remove fields inside the message. In the older version of the application, they will simply discard the address part because it's an optional field. And in the newer version, they will consider it. Just to keep in mind, because here is the example of Proto 2. In Proto 2, we had this required fields which cannot be removed, because if we remove this, it will break the code. But in the newest version of Protobuf, which is Proto 3, we can all the fields are optional. Another interesting part of it that I use in my project, because we can define a message with a payload which contains several messages. So the message was serialized using this proto file. But if I am only interested in the message like dataset and metric on the client side, so I don't need to create the deserialization code, deserialization code for metadata. So I can simply discard it, and I can just compile your for metric and dataset, and it will work fine. So in some case, when there are several teams working on the same project and they want some specific part of the message, they are able to do that. So coming to Scala PB is just a protocol buffer compiler for plugin for Scala. Basically, it will generate the case classes as and currently supports Scala SQL, Scala JS, and they support conversion from to and from JSON. And they have this option to user-defined functions as well. And in the latest version, there is support for gRPC, which is pretty cool as well. So, and the best part is like they support Proto 2 and Proto 3. And if you are using some like Java code to serialize or deserialize your messages and you want to take your code to a Scala part, so there in Scala PB, the both codes, they can coexist at the same time. So with time, the transition from Java to Scala is very easy. And to update any fields, Scala PB, it uses lens. So in that sense, it's very easy to update like nested fields. So if I talk about nested fields, like here, if we go to this example, because here we have in person, we have our address. So using the lenses, we can easily go from person to address and change the zip code if we want. So coming to the Spark part, in Spark, we can just use very easily the part of to deserialize any message who is serialized using this Google Protobuf. But there are some problems because normally the Spark uses encoders, and the encoders, they support only primitive types. So if you are going to use some non-primitive types, your code is going to be filled like here. It will say like no encoder found for certain types. For that, Scala PB, it has their own types where they take all the other types. So it's suggested to use your the Scala PB implicits and instead of Spark implicits. So now we have some optimization because in Spark streaming, when Spark streaming is like very long running process, and it's very often or it's very evident to find some memory issues. Like we usually, if you code in Scala or sorry, Spark or Spark streaming, you must be familiar with the out of memory error on the executor or on the driver side. The best option for these type of cases is to increasing memory, but as the memory is very limited, we cannot keep increasing it all the time. And there are some tunings that we can do on the executor and driver's part. Uh, but there are another scenario where we can tune our garbage collection, which is which I found is very important for Spark streaming process. Like here, to avoid very long garbage collection pause, we can tune our executors or we can tune our drivers. Like in executors, we have these JVM options. Like we can use garbage first and collector first, where the garbage collection will select a region with the least live data first, or we can ask for JVM to pre-touch in Java heap, and in which during the initialization of page, it will demand zeroed initialization instead of incremental. And we can use some large memory pages. You can use we can use TLabs. TLabs is like a thread local allocation buffer. And we have the option to resize the TLab as well. And we can set a soft goal. We can give a soft goal to the JVM using the max garbage collection pause milliseconds. Like it's a very soft target. Like JVM, it won't guarantee that it's going to achieve, but it will try its best to achieve this goal. So that's the part for the executor, but on the driver side, like if you're using lots of aggregation, and in many times we have this problem on the driver side as well, where when we apply aggregation like collect or any aggregation that you apply, we can apply the same same optimizations on the driver side. So I think that was all from my talk. It is like very lightning talk. So I wanted to do an demo, but for now, I think this all I wanted to say. Thank you very much. And if you have, you can find the slides on this link. And if you have any questions, I'm ready to take it. So in this case, like as I was saying, so for the SCADA systems, the proto file is like this. So we have this payload which takes the template a message like templates, where we can have these optional fields or another messages inside it. But the interesting part, like the part that we use in our project, is just this metric. So when I am going to deserialize any message, I will take only this metric part and all the messages inside, like metadata and property set and metric values. And when I will, because in Scala PB, the best part is like we have to just compile our our code, and it will generate the equivalent case classes for it. So the generated case class for this message, it's like it's going to be very long. Yeah. So we can have a look on the case class. Like, so it will be something like this. So for all the optional fields, it will be set to none or 0 by default. And they have all the others, getters and setters inside it. There's another example of this person message. Like here, it's using Proto 3, and I can add another field, like I can add another field inside it. Like if I want to add like address and phone number, and like I will say just some random ID, or like what can be the best example? Like if I want to check the last login for this person, login device, sorry. Yeah. So I can just give it a number, because when the message is serialized, it's like key value pair, and in the bytecode, if when we are going to deserialize the message, it will look for this number 5. With over time, I want to change, like, okay, I want to change the name of this field, like it should be something else. So I can change it, and it won't affect, or it won't break anything on the client side. So we have this flexibility with the Scala PB or Protobuf. So we can modify the names, or even we can delete the names, delete the fields. Like tomorrow I decided to delete this field, I will decide, and it will work as before, because for all the fields which are not present, they are simply going to be ignored. I think now I think is all that I will say. It's a very good library. If you are ever going to use a Scala PB, sorry, Protobuf, I think you can use a Scala PB if you have the option between XML or JSON. And because if you are going to use the JSON, it will take very much space, and if you are constrained with the traffic, or like the network traffic, the compact version of Protobuf is pretty fast over JSON. Even like to change the fields or to update any field inside a JSON is like tree-like structure. You have to go down, and after the time it gets very messy. But using Protobuf programmatically, it's very easy to update fields.
Now you have latest Spark Scala, or you have version back?
Actually, we are using is Scala 2.11.8, and what I have found like is the most stable version, not most stable and most used version of Scala in Spark. Because in the latest version of Spark, I think we can use Scala 2.12 as well. But in my like daily job, we are still using 2.11.
And you use MLlib from Spark, or you have own ML implementation of the Spark?
Currently, no. Currently, we are using like available libraries. We haven't developed anything because as where I work exactly is at the client sides. I'm a consultant, so usually they don't have this kind of teams to develop anything in the house. Because even if consultants they develop anything and they leave just to maintain any library, it can be a burden for them. So even if like we propose anything, they tend to say we will use something which is already available and maintained by larger public. And this is very interesting. Like in the domain of data science, the thing is like in most of the cases they use Python for their development, and Python is not very fast. Sorry to say that. But when you encourage someone to use Scala for their machine learning, they don't find lots of libraries in Scala. So, you know, like we are stuck somewhere in between. And there's another important point that I usually find with not only with data scientists or with data engineers as well. Like if we have developed anything using Scala or Scala Spark or Spark and Python, is just to optimize the code. Like when you develop anything on a smaller scale just to do a quick test, it works really well. But when you scale up with the data coming every day, or for streaming, if we talk about Spark streaming, like data coming every second, and when you do any aggregation on the whole data set or the data from several months or several years, it doesn't scale really well. Is to understand like what we do exactly, like we keep adding memory to our jobs that we are running, but after some time you cannot increase increase the memory because it's limited. And in that case, like we go back to the, we have to refactor the code from the beginning to optimize at the code level, not at the hardware level. And for me, it's very difficult to make someone understand like how exactly it works behind the scene. Like even for data scientists, I'm not against them, but they tend to use on a single machine. But when you are using a cluster, you cannot use the resource of a single machine to do all the calculations. So in that case, we encourage them to, but just by showing their, how many threads are running behind, how much memory they are using, how to, parallel programming, parallelizing their program so that it's more efficient.
And you rewrite algorithm from Python to Scala?
Not yet. I haven't got the occasion, but sometimes like to optimize, yes. Actually, yes, I do. I did. Last year, I think it was last year. Like it's been 2 years now. So there was some code written in Python, and it doesn't scale as I explained. So we wrote everything in Scala, and it's in production now. So I hope it still works. So and that's the because there were some Python developers, and that's the best way to show someone like the the importance of new language. In this case, in our case, it was Scala. Just to show them, and they were very interested to learn a little bit. So from in a team where you have only 2 Scala developers, and now we have 5 of them. So yeah, so for me it was a good learning for others. Their data scientists, they use R as well. So sometimes it becomes very complicated to work with all these technologies when but at the end we use the data, so it doesn't matter like how you're using it, but to get the data where I'm working right now, we use mostly Spark and with Scala, like to for the ETL projects.
How you productionize the data science?
So if I understand correctly, your question is like how we work with like data scientists who are using R.
Yeah, definitely, yes.
So for us, like for data scientists, the most valuable thing is the data. So what in our current stack, we are getting the data from various sources. We clean the data, like we ask the data scientists in which way they want the data, like to model the data. Like from the denormalized data, we normalize the data inside our code. And then we store the data inside the SDFS. I'm talking about our current stack is like we are using a Cloudera distribution. So to get the data from various sources, you can use a Spark or Spark streaming, but to store the data, we are storing inside the SDFS. And you can query the data using Hive or Impala inside Cloudera, or you can use any JDBC or ODBC to use inside RStudio or in Jupyter Hub or any other data science tools or IDE. So coming back to your question, like when we work with the data scientists, we ask them the way like the normalized form of data that they want. We do our every computation inside our Spark Scala programming, and we store the data, and they have to just use this normalized data inside their code, and they use this data from JDBC in most of the case, like for JDBC for Impala or Hive, and they query the database directly inside R or Python or if they are using any other language. And what they do, like to write the data, they write inside the SDFS. So there's no direct link between these two programming languages. It's just the data, which is the common part between us.
Okay, I got it.
I have a small question. It's Yuri. So so when it comes to data science and Spark, there is a certain learning barrier, I would say, for adoption for data science community. So I mean, people still need to learn Scala or Spark API itself. So what do you think about what can lower this barrier and what can make Spark in particular and Scala more popular among data scientists?
Yeah, so it's a really good question. I still think about it because I said earlier as well, like what appeal to the data scientists is the libraries that they can use to the models which are available. So if we can create libraries for data science, it will appeal more data scientists to use Scala. So because currently in Spark, there is like a Spark ML part as well, where we can use the Scala, but it is not used as we thought like in the beginning, and that's the only blocking point. So the more libraries that will be available for data scientists, the more uses there are going to be. So currently, like the basic question will come back again to the data scientists who really want to develop any new library or to train their models using Scala. So for me, the blocking point is this: to have more libraries developed inside Scala, and it will appeal more audience. Like in this case, it will appeal to more developers and more data scientists.
Okay, thank you.
There is one more solution taken in my organization. So currently we are having new data scientists, mostly among big data developers who are already trained to use Scala actively, right? So, and practice shows us that this transition works very well. So instead of hiring someone from the market with just having pure knowledge of Python, right? So we are training people from big data, actually originally from Scala world, and then they became big data developers, and after it they became data scientists.
Yeah, I think that's a really good solution as well. Like to train a data engineer who is using currently Scala to learn about data science as well.
From my experience, it's not such an easy process. Why? Because data science mindset and engineering mindset, they are quite different. I believe you can't get great data scientists from great engineer and vice versa. So the solution, on my behalf, is to get good engineer, bring good data scientists, and find the best way how they can communicate via data in Hive, via some tool, and etc. But data scientist is for science, engineer is for engineering, and it's a bad idea to mix them in one person. That's what I do.
Yeah. No, I agree with this thing. Like working together will make things easier.
Yeah, guys, no, it's an ideal world, I would say, right? So that we are having both guys available and ready to collaborate and do it smoothly and so on and so forth. So in reality, mature big data engineers are willing to have some space for further growth. And in most cases, they are willing to go to data science after it, in most cases. And that is why this solution, to provide them some such possibilities to grow in this direction, works. So it works on practice of 2 years in our organization. So we develop, and actually at the end, it saves time because we get motivated new data scientists, right? So who are eager to bring some value, right? So they are very familiar with all big data tooling stuff, and they're using it very organically, I would say, right? So, and does not need to have someone, to collaborate with them so intensively, and so like in previous scenario. They can be supervised, of course, and they can get support, but this time is very limited. So one data scientist can supervise 5 such new data scientists recently came from big data.
Okay, and how do you do and how do you do this? Like you organize training days where you get someone from outside world to train your data engineers inside data science?
We spent quite a lot of energy, paying a lot of attention to building our own internal learning courses, distance learning courses.
Okay.
So learning program to become data scientist takes about 1 year. So mature big data developer, has it like an educational goal for 2 reporting periods, so half a year. So and it is discussed on performance review meetings, and actually it set like a goal, so to get transferred to data scientists. And if the person really wants, right, so we organize his or her own working process in such manner to have some time to learn something new, like in data science area, right? So and from project to project, we increase the part of data science tasks, and it becomes more complicated, you know, and be more data science oriented. So, and within 1 more year, so we having quite good performing and motivated data scientist who uses all big data stuff very good.
Oh, that's really interesting to know.
Including Scala, right? But the key point is a lot of efforts should be spent for building these learning programs, internal learning programs. But there is a trick, so we inherit some external courses and just extend it with our materials, our quizzes, our mentorship, our capstone projects, and so on and so forth. So we just get something external and improve it.
Okay. Oh, that's really interesting. Like, I think I will propose the same thing in my company to to train data engineers to become data scientists at the same time. That's really okay. So okay. Thank you, everyone. Bye bye.